Today, we start by recalling why we really need the counting rules. And that is, if you're dealing with sample spaces having so many points, it becomes very hard to calculate by starting at the probability of the first sample point until the last sample point. Let us likewise recall that we can use our knowledge of the basic probability relationships to compute the probability of an event without knowing all the sample point probabilities. Let us go to the MnRule, or as often called the multiplication principle. But first, for those who just started watching my videos, this is your ma'am Viche. I do hope you can subscribe to my channel. According to the rule, if an experiment is performed into stages where there are n equals the number of ways to accomplish the first stage and n equals the number of ways to accomplish the second stage, then, therefore, the number of ways to accomplish the experiment or for an event to happen is equal to n times n ways. The MN rule can be extended to case stages, and this becomes a multiple-step experiment. So let us say an experiment has case steps, where the first step has n1 possible outcomes, the second step has n2 possible outcomes until the case step with the nk possible outcomes. Then, to compute the sample points in the sample space, you have to multiply all the number of possible outcomes, thus n1 times n2 times n3 times until you reach nk. For example, recall that a coin has two sample points, the head and the tail. So, if you toss three coins, the total number of simple events is 2 times 2 times 2, and that is equivalent to 8. For a dice with 6 sides, equivalent to 6 sample points, tossing 2 dice will give the total number of simple events as 6 times 6, and that is 36. And if you toss 3 dice, it will give you 6 times 6 times 6 equal to 216. Now, let us analyze the probabilities. Suppose there are 3 persons randomly selected from a large population of half females and half males. What is the probability of each event? Using the tree diagram, we will be able to see the number of possible outcomes, the sample points in the sample space of each outcome, and the probability of each event to happen. To construct the diagram, let us remember that when you select 1 person, there are 2 possible outcomes. That is, you either have a male or a female. So we draw 2 branches from the starting node, one representing male and the other for the female. For each of these 2 possibilities for the first person selection, there are again 2 possibilities for the second person selection, still male or female. So from each of the nodes, we draw again 2 branches representing the male and the female, thus giving 4 nodes. And for each of the 4 nodes, there are 2 possible outcomes for the third person. So we repeat the process to finally end up with 8 nodes corresponding to the 8 outcomes. Therefore, using the formula that the probability of an event is equivalent to the number of outcomes for an event to happen divided by the number total of outcomes. Therefore, the probability for each outcome of each event that it will happen is 1, that is 1 for each event, divided by the total number of events, which is 8. So we have therefore the computation for the probability of each outcome is equivalent to 1 over 8 or 0.125. Notice that if you use the NN rule, We can calculate the number of outcomes knowing that every time we select a person, there can always be two possible outcomes, male or female. Thus, selecting two persons, we start with the first person equals to two outcomes. The second person is still two possible outcomes, and the third person is still two possible outcomes. So, according to the MN rule, the number of ways that this outcome will happen is the product of all possible outcomes. That is 2 times 2 times 2, which is equal to 8. Also, to know the sample points in the sample space, just follow the path of the branches. So we have the F followed by F, then followed by F. And the sample space, therefore, includes the sample points F, F, and F. Now, let us follow another path. We have M, then F, then N. So, our sample space includes the sample points M, F, N. Take note that you have to follow the sequence of the sample points. Expand the problem. Instead of finding the probability of each event, the question now is, what is the probability of selecting two females? What are we going to do now? Well, we just have to look at the outcomes in the tree diagram. So where are the outcomes with two females? There are three of these outcomes, each with a probability of 1 over 8. So the probability of these events to happen is the sum of each probability. Thus, the probability of selecting two females is equal to 1/8 plus 1/8 plus 1/8 equal to 3/8 or 0.375. Let us have another example. This time we will determine the probabilities for the academic performance levels if we are given 75 examination results in engineering data analysis EDA. Thus, our sample N is 75, which are organized by course Chemical Engineering CHE, Civil Engineering CE, Geodetic Engineering GE, and Mechanical Engineering ME. Then they were again grouped by academic performance level per course. That is, BB represents below basic performance level, B is basic performance level, P is proficient performance level, and A, advanced performance level. Now, let us have our tree diagram. There are two steps involved. Step 1 is organizing the data by course, and step 2 is organizing the data by level of academic performance for each course. Thus, in step 1, there are 10 exam data from the CHE, 30 from the CE, 15 from the GE, and 20 from the ME. So, in step 2, we have also the BB, B, P, and H course with the corresponding number of students who got those particular academic performance level. So how many outcomes will we have? Take note that with 75 students, the number of total outcomes possible is 75. And now we need the formula again of the probability of an event. That is, we divide the number of outcomes in the event, that is NE, and then divide it by the total number of outcomes, N. Compute for the probability of selecting a student with below basic performance level, P of BB will look into the number of students per performance level with a BB value. There are 3, 5, 5, and 0. So the probability will be P of BB equals 3 plus 5 plus 5 plus 0 divided by 75, and that is 13 over 75, or equivalent to 0.173. Want to get the probability of selecting a student with basic performance level B, that is the P of B, will be equivalent to, we have the CHE B is 2, CE B is 4, GE B is 5, ME that is 8. So the probability therefore of B is equivalent to 2 plus 4 plus 5 plus 8 divided by 75, and that is equivalent to 0.253. We'll do the same for the rest. For the probability of selecting a student with proficient academic performance, PFP, it will be equivalent to 3 plus 16 plus 3 plus 7 divided by 75, and that would be equivalent to 29 over 75, or 0.387. And for the probability of selecting a student with advanced academic performance, P of A, it will be equivalent to 2 plus 5 plus 2 plus 5 divided by 75, and that is 14 over 75, or 0.187. Again, if you add up the probabilities of below basic, proficient, and average, the sum of P should be equivalent to 1.0. If it does not add up to 1.0, something must be wrong with your solution. Sometimes it is due to the rounding off of your answers, so check your solution. So, guys, on the next video, we'll be discussing the counting rules, specifically permutation and combination. I would greatly appreciate if you will subscribe to my channel, and of course, please also hit the like button. Thank you.